Hello from Italy, and welcome to our virtual talk, The Rise of Potatoes, Privilege Escalation in Windows Services, and not only. As Cooper said, this is not a pre-recorded talk, but it's a live streaming. So first of all, I want to apologize for my bad English and for some mistake, but as you can imagine, I'm not able to stop and to record again. Okay, so I hope that all we talk about is clear to you. Okay, back to us. A little bit about me. Yes, I'm Andrea Pierini. I'm an IT architect and security manager with a long experience. I'm also passionate about IT security, and during my spare time, among other hobbies, I sometimes like to do some research and find the vulnerabilities, especially in Windows environments, and especially with my friend Antonio. If you want to get in touch with me or read my blog about my findings, these are the contacts. And now let's go to Antonio.
Okay. Yes, thanks, Andrea. Hi, everyone. Welcome to our live talk. I'm Antonio Cocomazzi, and I work as a system engineer at SentinelOne. My main interests are in malware analysis, reverse engineering, Windows internals, and offensive security. And on the right, you can find my public channel. You can find my Twitter account and my GitHub account, in which I often publish my researches and also my offensive tools. I'm also a CTF player, and I enjoy to play in my free time. And I'm also a proud member of Donkey's team. Back to you, Andrea.
Okay, so first of all, why this talk? Well, the initial... Can you please go back, Antonio? So our initial idea was to, if you can give me the previous slide. Well, this is live streaming. Some technical problems can happen. Okay, why this talk? Because our initial idea was to give you an update on all the techniques we discovered, but not only, but also other researchers, to perform a privilege escalation when you have a compromised service account by abusing impersonation privileges. So in the last years, the rotten and juicy potato exploit were heavily used to abuse these privileges. But starting from 2 or 3 years ago, Microsoft silently fixed this, and starting from a certain Windows version, it is no more possible to abuse with our potato exploit. So we decided to do some research in order to find some workarounds, and this will be discussed in our presentation. But at some point, we asked ourselves, can we get rid of the impersonation privileges? Do we really need impersonation privileges? Because what we had in mind was, if we can use our potato techniques without impersonation privileges, so that a standard normal user can escalate privileges, this would be really, really fun and also dangerous. Okay, so next slide. Okay. Very quickly, the agenda. We will first introduce some basic concepts. I think these concepts are well known to all of you, but about services, we'll talk about services and impersonation essentially, but I think it's a good starting point for the next step of the presentation, where Antonio will speak about all these techniques to perform privilege escalation by abusing service account. Finally, we will show you how we were able to relay our potatoes, and then we will give you some hints about mitigations and then the final conclusions. Okay, let's start with the Windows services. What is a Windows services? Well, it's a particular process which runs in background in a separate session and without user interaction. It's very similar to a classic Linux daemon. Why is the service so important? Because, as you probably know, all Windows components are running through a service, and being daemons, they have an exposed attack surface and a very interesting attack surface, because usually they run with high privileges. The Windows services must be run with a special type of user. It's the service user account, and the configuration of the service are done to dedicated registry keys. How can you recognize a service from the process point of view? Well, first of all services have as the parent process the services.exe, which is the service control manager. They live in session 0, and from the programmer's point of view, they make calls to dedicated APIs in order to interact with the service control managers, such as SV install, SVC main, control ender, and so on. How does the kernel recognize a service? Well, in the access token of a service, there is a special group, a special seed, which is the service seed group. So if a process, if an access token of a process has this belongs to this group, it will be a service. Then we have the service account. So in order to run a service, you need a special, let's say special Windows account. And this Windows account don't need to have the password managed. The password is managed internally. We have different services account type, the local system, which is the most powerful. Then we have the local service, network service account, and finally managed and virtual accounts. All these accounts have to be granted the right to log on as a service, which is the logon type 5. So you can even run a service with a standard user, so normal user you create, as long as you grant to this user the logon as a service right. So since in the earlier Windows version, starting from up to Windows 2003 and XP, all services run as system. As you can imagine, this was very dangerous, because once you compromise the service, you compromise the old machine. So some mitigation, which that Microsoft called Windows Service Hardening, came to rescue. At least this was the initial goal. You can find some great references here in the bottom of the slide. So let's understand better what exactly Microsoft did in order to harden, to restrict the power of the Windows Service account. Well, first of all, they introduced two special accounts, local service and network service account instead of system, which has less privileges than the system account, but they still have impersonation privileges. You can also restrict the privileges of a particular service via configuration in order that you can assign to the service only the needed privileges. So if a service does not need the impersonation privilege, he will run without this privilege. This is the least privilege best practice, as you can understand. Not only, you can also assign to the service a write restricted token. What does this mean? That the service, by default, has only read access to the resources until you explicitly grant write access to dedicated resource. This is a fine-graining and very powerful way to limit how can I say that? To limit the service. Okay. Then we have also the service seed and virtual accounts. This means that each service, its access in the access token of each service, there is a unique owner seed. Each service is a unique user, okay, which has a unique owner seed. This seed is not shared across different services, and you can assign specific permission to the seed. So if you need to let only this particular service access a folder, a file, or what else, you can fine-grain this too. Services live in session 0, as we told before, and this should, in theory, not interact with other sessions. So it's a safety boundary. Services also run with a particular integrity level, which is the system level. We have the low level, medium level, high level, and system level, which is the highest one. And this is useful in user interface privilege isolation. What does this mean? That a process running with a lower integrity level cannot send messages, cannot interact with a service, with a process with a higher integrity level. Having services the highest integrity level, they are protected. Oh, sorry for, okay. Now let's talk a little bit about impersonation. Microsoft says impersonation is the ability of a thread to execute in a secure context that is different from the context of the process that owns the thread. What does this mean? It means that impersonation means that you can execute code on behalf of another user, and this is impersonation. So in order to execute code on behalf of another user, you have to obtain the token of this user. And once you have obtained this token, in order to impersonate this token, because then you can run a process or a thread on behalf of this user, you need a special privilege. This is the impersonation privilege. And this is the prerequisite for all the techniques we will be shown, except our remote potato zero exploit. So what is the link between services and impersonation privileges? Well, if you run the group policy editor, under the user right assignment, you will see that all the various service accounts, including the service group, have this privilege granted. If you try to remove this privilege, Windows will warn you, sorry, you cannot do that, but because by default, the service account needs these privileges. Okay, this was all. I hope it's clear. And now we go to the juicy part, which Antonio will show you. Back to you, Antonio.
Okay, let me take control. Yeah. Okay, in this part, I'm going to show all of the techniques in order to achieve privilege escalation, starting from a service. So once we have compromised a service that runs with a service account that all these impersonation privileges, you can run one of those techniques in order to escalate your privileges to the system account. That is the most privileged user on the system. What I'm going to do is to list all of these techniques with all the various details clearly by ordering in the release date. And consider that all of those techniques are being classified as one fix. So all of these techniques will work on every updated Windows machine. Let's start with the first one, Rogue WinRAM. Rogue WinRAM has been released on 6th December 2019 by the coder, that is Andrea, Splintercore, myself, and Roberto. And briefly, what does this technique? It's tricking the bit service that is running as a system to authenticate on a malicious Rogue WinRAM HTTP server. And this will result in a NTLM challenge response authentication. And of course, what we have done is implementing this HTTP server that will perform this authentication over HTTP, and we are able to grab and steal the system token. What are the requirements of this technique? Is that the WinRAM port, that is the 5985 by default, is available for listening. And by default, this technique is useful only on Windows clients, because as you may know, on Windows servers, the WinRAM service, it's running by default, but not on Windows clients. How we recognize this strange behavior? So let's start. What is the strange behavior? The strange behavior is that every time you try to instantiate a bits object, okay, the bits object will perform an authentication to the WinRAM port, that is the 5985. So if no one is listening on this port, this will go to, this bit service will shout no one, okay? And what we have done is to just inspect what is received, what we receive on this port with a classic netcat listener. And what we have observed is that we receive this privileged authenticated request through HTTP in the classic negotiate header of the HTTP header. So our idea was, what about if we try to authenticate this authentication? So we perform the NTLM challenge response schema, and we'll see what kind of token will be given back by this service. And this is what we have implemented here. RogueWinRM is basically a minimal web server that performs end-to-end authentication over HTTP. Here I'm showing a little picture in which on the left there is the DCOM, and in our case it's the bits object that is trying to authenticate to us. And on the right there is the server. This server is run by our RogueWinRM. So let's start on the first message that we received. The first message we received is the type 1 message, the negotiate message. And this message, we received this message. Of course, this message is base64 encoded, so we unpack this message, and we will use the API offered by Windows in order to accept this security context, and the code is called accept security context, and magically this will perform some RPC connection to LSAS. LSAS will give back us the type 2 message. This type 2 message, we just encode it in base64 and we send it back to the client. Like we just are following the classic protocol NTLM, okay? And once we give back this type 2 message, magically our DCOM will send back us the type 3 message, that is the authenticate message. And once we receive this, we can call again, accept security context, and magically LSAS will create in our process space the security context of system. And once you have in your process space the security context of any user, you can just query for the token of this context. And of course, it will result in what? In a system token stealing. This is a demo that I have drafted. On the right, I am the attacker, of course, and I'm preparing my listener to receive the connection of the privileged process, so the process that will be run as a system. On the left, I have the attacker that has been able to compromise a service process that is running as local service. The attacker check that this service process holds impersonation privileges, and the attacker will run RogueWinRM, our exploit, and will ask to run a privileged process to send a reverse shell back on the local host, okay, on the port that will be run the netcat listener. And what will happen is that all the flow that I have explained in the last slides will be performed by our tool, by our RogueWinRM. And in the end, WinRM will tell you, okay, I have created the system security context. I am able to create a process with this token, and magically our listener that is waiting for the privileged connection will finally receive the process running as a system. And of course, the attacker has achieved local privilege escalation with this technique. Let's jump on the next one. Next one is Rogue Potato. Rogue Potato has been released on the 11th of May, 2020. Authors, Andrea and myself. Brief description, how it works, briefly. So we tricks the DCOM activation service in contacting a rogue auxiliary resolver under our control. And this, we have written some code in order to force RPCSS, that is the DCOM activator, that is a very privileged process, into writing to a controlled enabled pipe, and this will result in an authentication over an enabled pipe by network service account. But this network service account, we will see that is, in reality, it has more privileges than what it should have, and we are able to abuse these privileges in this token and perform the token kidnapping technique to steal a system token. What are the requirements? The requirements are that the machine, the attacked machine, can make an outbound connection port 135, that is the auxiliary resolution that will be performed in a malicious way, and of course SMB running and DCOM running. So let's split the attack flow of Rogue Potato in 4 main steps, okay? Because the attack is quite articulated. The first step, step 1, we are just tricking the DCOM activation service by trigger the iStorage object. What it means. This is a discovery by James Forshaw in a vulnerability in 2015, in which he found a way to trick the DCOM activation service with a particular marshaled object. Okay, so how it works? First, we pick a CLS-ID to create an object activation request. So a CLS-ID is just an ID to identify a class that will be implemented by an object. Okay, and once you pick a CLS-ID, you are just telling the DCOM activator to impersonate the user configured for that class. Okay, of course, in our case, we were interested in the CLS-ID configured with the system user. That is the most powerful on the system. Once the object is created, we initialize it to a marshaled object. So we just give some raw string bytes. And of course, this object will be, it will inherit the properties of the iStorage object, because this is a way to activate particular objects in the activator. In the marshaled object, we are following a particular, that is, of course, just a stream of bytes. We are following a particular standard, that is the object ref standard, that it allows to specify particular headers of the bytes of this marshaled object. And in one of the header, you can specify the IP of a OXI resolver. And what we have done is to specify the IP of a remote machine that is under our control, and will implement a malicious OXI resolver. So when the activator will unmarshal the object, what it will happen is that the activator will say, okay, this object, I need to query this OXI resolver remotely, because I'm not able to give the proper binding information of this object. So this will trigger a OXI resolution to our malicious server. Step 2 is exactly what we have done to implement this malicious OXI resolver. So the OXI resolution is made through this call, resolve OXI2 call. And what we have done is to implement this RPC server, that is our rogue OXI resolver, and we have written the code to give back to the client, the victim client, a poisoned answer. So at first, we listened for connection on the port 135, that is the default port used for the OXI resolution. And we, in order to not implement a OXI resolver on Linux, we have forwarded this resolution back to the Windows machine that will run the OXI resolver. So at first we have run a network redirector. And of course, on the machine, on the client, we have implemented our rogue OXI resolver with the RPC runtime function that Windows offer. And we have written the code for the resolve OXI2 function. What we have done in this poisoned answer, at first we told the client to use RPC over named pipe, that of course will use SMB as the transport protocol. And the second thing is that we have used a path validation bypass bug. Okay, so in this way, we are tricking the client into contacting a named pipe that is non-existent. This technique has been borrowed by Clement Labro and Jonas in one of their techniques called the Priv spoofer, that I will show in the next slides. So what we have done is to use a binding information. We are using a slash, and what they have found out is that using the slash in the host name of the binding information, it will be converted in a prepend of the path used for the named pipe. So the activator, RPCSS, instead of using the default named pipe, that is pipe IP mapper, it will try to connect to a non-existent named pipe. So pipe rogue potato, pipe IP mapper. And this, of course, if someone can intercept this connection, it could be impersonated. And this is what we actually done. So there is someone that is trying to connect to a named pipe non-existent. So we run a listener on this named pipe, and we try to impersonate this connection. So how we realize this function? Very simple. We just used the Windows function to run a named pipe server on a specific named pipe, consider that every user can run a named pipe on every pad, but of course that pad must not be already busy. Okay, in this case, that was the case. So this pipe was free and no one was listening on that. So we have run this named pipe server and we waited the connection from the privileged authentication and we call it impersonate named pipe in order to impersonate the client. This is something that is enabled, that is available, and that is allowed on the Windows if you have impersonation privileges, of course. So once we have done this, we thought, okay, let's investigate the kind of permission we have in the token. And of course, what you have we've seen is that, yes, we got an authentication as network service. We expect an authentication as system, but in this case, we got an authentication as a network service. And the impersonation level of the token is impersonation, so it could be useful for us for use this token because we could impersonate and achieve code execution with this user. And the thing that we have advised some moment later, it's a very powerful thing. We have seen that in this token, yes, it's a network service token, but it contains a very powerful WD that are the WD of RPCSS. That is a very critical process. And that was a nice surprise for us because with this, the first thing that came in our mind is that, okay, we are able to open and grab still the token from RPCSS. That is bingo. And the step 4 is exactly what we have done. So we have all the requirements to steal this privileged token. Let's just implement this technique that is called a token kidnapping in order to steal this system token. This is the last the last step, sorry, of the chain. And this is the token kidnapping technique that it's a quite well-known technique. And the first time has been discussed by Cesar Cerrudo in 2008. And what it basically does is that once you have the rights to open and duplicate a remote process, you can get all the handles of this process. In this case, we were interested in the process ID of RPCSS. And what you have done is opening the process, list all the handles for each handle, try to duplicate it, and get the handle type. And if the handle type is a token and owner of this token is system, it mostly represents a system token. So we try to impersonate it and launch a process with this token, with one of 2 API calls that Windows offer. And of course, in the end, what we will have, it's our process that will be run with this very powerful and privileged system token. This is a demo that I have drafted. So what we have here, we have on the right, the attacker, and the attacker is the machine 10006. And on the left, sorry, it's 10003, the attacker. And on the left, we have the attacker that is connected on a web shell that he has been able to upload on this web server. And that is the 10006. So the attacker, in this case, has been able to upload a web shell on this IS web server. For example, he could have achieved a exploitation, a remote code execution, or a SQL injection by writing a web shell. And the first thing he wanted to achieve is what? Is to run code not with the application pool, but with the maximum privileges on the system, that is a system account. So it runs a rogue potato. At first, of course, it runs the netcat listener. Okay, so this listener will receive the privileged process running as a system. Then it runs the redirector in order to forward the malicious OXI resolution back to the Windows machine that will run the rogue OXI resolver RPC server. It checks the actual privileges of his web shell, and this is configured with the default configuration of IIS with the default app pool. And this configuration will give this account impersonation privileges. This is the actual default configuration of every IIS web server. And then the attacker run rogue potato and tell to rogue potato to run a process with the reverse shell, with netcat, for example. So rogue potato will start his magic. It will start all the threads that will implement what? All the steps that I have just shown in the latest slides. So the first step will trigger and will trick the DCOM activation service. So we pick an arbitrary CLS ID. In this case, we use bits, okay? That is our favorite target for this kind of attack. And what it will happen that, of course, we will send the marshaled object, the raw stream bytes of using objref standard. And once the activator will unmarshal this object, it will find the IP of our Linux machine, and it will try to make an outbound resolve oxid resolution to our Linux machine. Of course, as we said, we forward back this resolution to the RPC server running locally on the target machine, on the victim machine. And on the victim machine, we have the thread that is getting this oxy resolution, this malicious oxy resolution, and it will answer with the poison and answer. So in this way, we tell to go to connect to our malicious named pipe, that is pipe rogue potato pipe IP mapper. And then we go trigger the step 3. The step 3 is exactly our activator that is connecting to our named pipe, and this thread will impersonate this connection and will just perform the token kidnapping technique. And the token kidnapping technique is telling us, the step 4, okay, I was able to grab and steal the token from the process space of RPCSS, and then it creates a process with this token. And in the end, what we have is that the attacker has been able to achieve local privilege escalation with the system account in this way, with this technique. Just a note on rogue potato. Rogue potato is very powerful because it works by default on every Windows client and server installation. Then we have GC2, released on 13th of May 2020 by Andrea and myself. How it works, it works very similarly to rogue potato, but in this case, we use RPC over TCP instead of RPC over named pipe. What are the requirements of this technique? That, of course, the machine must make an outbound connection to port 135, DCOM running, and by default, this affects only Windows clients, no Windows servers. And I will show in some moments why. So as I said, GC2, it's very similar to rogue potato. So instead of using RPC over TCP, over named pipe, we are using RPC over TCP. So we are changing the behavior of the resolve oxy2 call. And of course, GC2 is Juicy Potato Reloaded, and that it works on latest updated Windows systems. Consider that Juicy Potato still works on older Windows installation, like the one before 1803. Okay, so you are able still to use Juicy Potato on those servers, on those machines, but for servers that are above these versions, you can use this or the others technique. So what it changed, of course, it's the step 3 or 4, it's different. In this resolve oxy2, we tell, okay, do not use anymore named pipe, but you use RPC over TCP. In this case, in the square brackets, you have to specify not anymore the path of a named pipe, but you need to specify the TCP port that will be used by the RPC server. And of course, we are returning 9999, and on this port, TCP port, we are running an RPC server that must implement the IRM2 unknown interface. And in this server, in this RPC server, we will impersonate the authentication, the security callback of the RPC server, and we will perform malicious, or at least we will run an arbitrary process of system in this security callback. Why there is some limitation with this technique? Because what we have found out is that most of the CLS-IDs that we were using returns an identification token. That, if you don't know, every token in Windows, it's not usable for achieving code execution. Okay, there are different levels of the token. You have delegation token, impersonation token, identification token, and anonymous token. The impersonation delegation token allow you to impersonate this token and perform operation on behalf of that user. Identification token, it does not allow it. It does not allow it. It just allows to perform limited operation on the seeds inside that token. Okay, for example, querying the groups, etc., etc. Why this behavior happen? Because by default on RPC are defined the security costs, that is this struct that you see here, and one of the field of this struct is it contains the impersonation type constant, and this constant is set by default to it's a variable, but it will hold one of the known constants for RPC impersonation level, and by default this value is set to identification. So every authentication is downgraded to identification token. But what we have found out is that it can be possible to override this behavior. So you can do this at code level, for example, by calling co-initialize security, or you can do it by with a particular registry key. That is the one that I'm showing at the bottom. So what we have done is just, okay, let's enumerate if there are some CLS-ID that could be useful for us, that will give us back an impersonation token instead of an identification. And this is the result. As you can see, there are some CLS-ID that instead of returning identification level token, it returns impersonation level token. And what we have found out is that some CLS-ID were impersonating another user that was the user logged on in another session. And this was crucial for us for the chapter that will be shown by Andrea in the next slides, the relaying potato authentication, because this was one of the things that helped us to get rid of the impersonation privileges. But let's get back to GC2. One of these, as you can see, two of these are run as a system, so return get back to us a token system, a system token, and one of it was a default service that is installed on Windows clients. Okay, that is the ActiveX installer service. So if you use this CLS-ID and you perform all of these operations that I shown, you are able to achieve privilege escalation this way. Unfortunately, this CLS-ID is not available on the Windows Service installation. So this technique is available only on Windows clients. Then there are other non-potato techniques. I just want to mention that those techniques are here not because are less important or less powerful, but just because for the name, you know, these are non-potato techniques. So the first one is the network service impersonation that has been discovered on 25 of April 2020 by James Forshaw. It discussed it in this blog post, sharing a logon session a little too much. And basically, he found out that there is an optimization that is performed by LSAS internally that could be exploited. So what he has found out is that if you can trick network service account to perform a loopback authentication over named pipe, you will find, and of course you need to be able to impersonate this authentication, you will find that yes, this token is still of yourself, network service, but inside it will contain a very powerful ID. So the powerful ID that this ID is the RPCSS ID that can allow you to steal the token from RPCSS that contains a pile of treasures, for example, the system token. And this is also something that you have used with Rogue Potato. If you remember, I talked about the token kidnapping technique to steal the token from RPCSS. Then we have Print Spoofer, 2nd of May 2020, discovered by Clement Labro and Jonas. And basically, they have found a vulnerable exposed RPC interface that is part of the print spooler service, and they have used the pad validation bypass bug, and they tricked this privileged process, a privileged service, print spooler service, into writing on a control enabled pipe of the attacker. And of course, once this connection to the named pipe occurs, they impersonate this authentication and will steal the token. At the bottom, I have been very quick on these techniques because the scope of this talk was more on the potatoes technique, but I strongly recommend that you read this blog post by them that they left at the bottom. So now it's the chapter of relaying potatoes authentication, and I will pass the ball to Andrea.
Okay, thank you, Antonio. I hope you agree that it was a really great overview. So, so far, what we saw is that we always intercepted an TLM authentication, trying to steal a token and impersonating it. What we told you at the beginnings is there a different way to abuse these authentications? And this is what we'll see in the last chapter. Oh, I have always problems. Can you skip, Antonio? Okay. Okay. What was our basic idea? So, what if we relay our RPC authentication triggered by our famous potato exploit instead of impersonating? Because if this is possible, we can get rid of impersonation privileges, and the standard user can escalate privileges. Okay, but the first problem is that we have to find a suitable authentication, because as you could see, most of the authentication taking place in our potatoes techniques were authentication performed by service accounts, system accounts, and so on. These accounts are not so useful if we want to relay the authentication to another host and another protocol. But, and Antonio already mentioned this, we also saw that there are some particular CLS-IDs that if they are activated from session zero, they will trigger the authentication of the first user connected to an interactive session. So imagine that if you have a shell as a standard user in a session zero, and the domain admin is logged in via remote desktop, for example, you can trigger the authentication of the domain admin, which is really cool, okay? Next slide, please. Sorry. Okay, I will try to skip the slides now. Okay, so NTLM relaying. In the recent years, most of the researches and subsequent mitigations about NTLM relaying were on protocols such as SMB, HTTP, LDAP, and so on. There is not so much documentation about RPC, and especially when we have, as in our scenario, we have to relay the authentication from an RPC client, okay? And what we did is, first of all, is it possible to relay the authentication from the RPC client to other protocols such as HTTP, LDAP, and SMB? We did some tests in our lab, and it worked. So that was a good starting point for us. It worked with some limitation. First of all, the client call has to set the authentication level the authentication level to connect, which is a very basic and most unsecure, let's say unsecure identification level. And then we have to bypass or take in consideration the NTLM, the mitigation for relaying, such as signing, message integrity checks, and so on. So this was the challenge. And in our scenario, in our potato scenario, two interesting NTLM authentication took place: the OXID resolution and the IREM unknown interface call. So let's see these two authentication more in detail. Okay, it worked. Magic. So if we trigger an activation of with one of these particular CLS ID, which I repeat, impersonate the current user, the client will perform an authenticated OXID resolution request. if we capture this traffic, for example, with a Wireshark, we can see that the NTLM authentication sign flag is set. So this is not useful for us. If you want to do relaying, we cannot have this flag set. What happens then? Next slide, okay. As Antonio told you, we implemented our fake oxide resolver, okay? And in our fake oxide resolver, we have several parameters which are under our control, and a couple of them are very, very interesting for us. The first one is the authentication level. We can here set the authentication level, telling to the client that all subsequent authentication should not be signed by simply setting the authentication level to connect. So we have control on this parameter. Not only, in the oxide binding string, we will return the connection information in order to let the client connect to our local relay server. How does we do this? Simply by specifying the IP address and the port to connect to, and also the protocol, which should be TCP. Then we have another interesting parameter that we can manipulate. It's the authentication type. What we discovered is that if we set it to win and a T, again, the subsequent authentication will not have the sign flag. If we set it, for example, to negotiate, the authentication, the sign flag in the authentication will again be set. So by controlling these two parameters, we are sure that the next authentication will not have the sign flag set, and potentially we can then relay this. What happens when we return to the client this binding information? The client will, Antonio already told you this, the client will perform an authenticated IRM release 2 call to our local relay server. We will intercept this call and then forward it to the real relay. And that's how it works. Okay, sorry, but I didn't click on the slide. Here we can see that the sign flag was not set, okay? So this is good for us. This is the IRM release call, sign flag not set, so we are, okay, we can relay this one. Okay, this was the theory, but now we had to implement it, and we implemented it in our tool, the Remote Potato Zero, our soul of the tool. And this is the big picture. It seems quite complex, but I think it's very easy if you follow me a little bit, okay? I will explain it as best as I can. But remember, I'm Italian, I speak with my hands, so if you look at my hand, probably it will be more clear. So let's start from the beginning. What do we need? A victim machine where a user, preferably privileged users, such a domain admin, is logged in. Then we need our attacker machine, okay? And this machine must be reachable on port TCP 135. From this machine, we need a shell on victim machine in session 0. This can be, for example, a WinRM, SSHL, or maybe also some vulnerable task, scheduled task, so that we can gain a shell in session 0. We will copy our exploit on the victim machine and we launch it. So the first thing it will do is to trigger our DCOM activation service with one of these particular CLSID. And in this activation service, we specify the IP address of the oxide resolver. The IP address of the resolver is our victim machine. So we will receive an authenticated call on our attacker machine, which we will redirect to the our remote potato exploit to the part who implements the rogue oxide resolver. And this is it. And then we will return again a string binding where we tell the client to connect to our local relay with the dedicated protocol, and by setting all these parameters in order to be sure that the subsequent IRM release call will not be authenticated. So in our local relay, we will perform a cross relay from RPC to our HTTP. We will then forward this authentication encapsulated this time in HTTP to our attacker machine where NTLM relay X is running. And then we will do the final relay to the destination host with the destination protocol, okay? We have now an animated GIF which will explain you how it is possible to perform this attack. For example, a standard user gaining domain admin privileges. It's an animated GIF and I cannot stop it. So I hope that I can synchronize. I will only show you some, say a few words, because I think if you look at the video, it's very simple to understand. Okay? Okay. Here we are. So we have a standard user who cannot access the domain controller, obviously, because they have no special privileges. So we will now obtain a shell in session 0 on the victim machine. Okay. This user, WinRM user 1, has no privileges. He can only do WinRM connections. Okay. And then he will launch our remote potato exploit with all the necessary parameters. Okay. The IP address, where we specify the IP address of our attacker machine. And then the port. And then we will clearly forward the Oxid resolution request to the remote potato running on the victim machine and finally launch NTM relay X. If everything was fine, I know it was very fast, but as you can see here, first of all, the WinRM user has now replication get changes privileges, and he's member of the domain admin group, so that he can now finally obtain a system shell on the domain controller. Okay, that's it. Let's check if he really is member of enterprise admin. Yeah, he is member of enterprise. So standard user can gain, in this scenario, domain admin privileges, and this has not been fixed. Last but not least, the strange case of SMB relay, because as I told you, we were also able to relay from RPC to SMB. But there are two limitations in this case. The first one is that obviously the sign flag has not been set, and also that the identify flag, which tells which type of token should be created, has not to be set, because if this flag is set, the SMB server is not able to impersonate the client. What we saw is that, for example, for the CLS-ID of the picker host, the identify flag was not set. And we had a quick and dirty idea. We simply unset the flag, and magically it worked. So we found a way to bypass this limitation. But this was true until the November patch Tuesday of 2020, because after this patch, we discovered that it was no more possible to perform this operation, altering the flag. So what it seems is that the method integrity check is always performed, even if signing is not enabled. But before this patch, the NIC was performed only when signing was enabled. Okay, that's all. Back to you, Antonio, with the conclusions and some news, okay? You are mute.
Yeah, sorry. Okay. Thanks, Andrea. Let me go back.
Okay.
So what news we have? So what we achieved is that cross-session relay is also possible. So what was the idea? Is that getting a shell in session 0 is not so common for regular users. So if we could have a way to achieve a cross-session relay, so for example, triggering the authentication of another user in another session, that could be much more impactful. So for example, a common scenario could be if you have a remote desktop session and multiple users are connected, or if you connect to a jump station machine. In reality, there already exists this the way to activate COM object cross session, and this is done through the session moniker. Okay. The problem with that is that you cannot combine the iStorage activation, that is the one that is used by the potato exploits, with the session moniker objects. But is it that really true? Well, luckily enough, James Forshaw, inspired by our remote potato, conducted his own research, and it demonstrates a way that with some undocumented way, there is the opportunity to target the session before triggering the storage object. So in this way, if you have any shell with any normal user on a machine, and you are able to grab and steal the authentication of another user that is currently logged on. Very, very powerful. And of course, we try to implement these two concepts, these two topics. So the cross-session, so the session moniker activation with the iStorage object, and we have found out that you are able to impersonate, to trigger the NTLM authentication of another user of another session, even if you are not from session 0, even if you have not a shell in session 0. So this is very powerful because you can get rid of the session 0 limitation. This is the last part, some mitigation in order to fight the privilege escalation through the service processes, service account, and also to fight remote potato. The first one is the opportunity, the configuration that you can make on the services in order to add the right restricted seed. That, if you remember, is something that Andrea talked about in the Windows Service Hardening chapter. And you can do this with the service control by just specifying seed type, specifying the service, and the attributes restricted. You can also use virtual service accounts, okay? Or of course, you can create also your own with some seed mapping that you can configure with LSAS that you can find in the article from James Forshaw. And if you want a practical guide in order to guide you, for example, make an hardened configuration of IS, you can find also the blog of Andrea that will guide you through all the configuration in order to restrict the attacker to not reach or achieve a process with impersonation privileges. And of course, the last but not least, you also need to remove the impersonation privileges by specifying the only required privileges for the service. Okay, so you can do with service control, specifying privs, name of the service, and all the required privileges for your service. Usually, your service depends on what it has to do, but usually it does not require the impersonation privileges. And some mitigation against the NTLM relay attacks that, by consequence, will also mitigate the remote potato 0 exploit is the classic mitigation for the NTLM relay attacks. So on the server side, you must configure token checking for HTTP. So if you configure it through group policy to allow, or if not require, it cannot be possible anymore to relay authentication over HTTP. For LDAP, you can configure the policy require signature for non-LDAP connection. So in this way, the server will always check that the signing is enabled. And for SMB, of course, you should configure the SMB signing by setting the group policy digital design server communication to always. This is already done to domain controllers. So you can also apply this to servers or client. But of course, make sure that you don't break anything else. Conclusion, for sysadmin is never rely on default Windows Service Hardening configuration for segregating the services, because remember that also Microsoft do not consider it a security boundary, but just a safety boundary. For penetration tester, always run via MyPriv, and remember that you have a series of techniques that allow you to, with one click, to achieve privilege escalation. For service provider, please do not sell web servers by sharing the same IS and creating a new virtual host, at least not with default configuration. And also, one last point that I want to leave you is that do not trust the multi-session user isolation because it can be broken by remote potato 0. Thank you all. Feel free to reach out. Those are our contacts, and we are more than glad to answer all of your questions.
Ciao from Italy.
Thank you.